Let's talk about random variables. Random variables basically are of different types. We have random variables as numericals. We also have categorical variables. So let's talk about numerical variables first. Numerical variables are basically also divided into two types. We have something called as continuous. We have continuous variables, and then we have discrete variables. A very simple example of discrete or continuous variables would be, let's say we're talking about a revenue of a company. Okay, we have revenue in a company. So let's say there is a company A that has a revenue of, let's say, $12 million. Now, one main thing about continuous variables is it's a major feature. Continuous variables can be anything over a particular range. It can take infinite values. Why infinite values? Is because let's say there can be any number of let's say there is a range of 12 million to 13 million dollars for revenue for a particular company. Now this can be divided into numbers like floats. Continuous values are not necessarily integer values. These are float values. These can be float values, these can be integer values, these can be any number of these values. So let's say it can be let's say $12.45 million or $12.6 million. It can be anything like that. And discrete variables, so basically the point is it can take float values, and discrete variables are variables which have to have integer values. Let's say age of a person or age of different family members, and we have a family member, let's say Emily, who has the age of 13, let's say. Now she cannot have an age of 13.5. Although when we talk about age, we say that a lot of people have the age of 13 years 11 months or 14 years 5 months. However, we don't really write age like that. We say either a person is 13 or 15. We don't normally say, okay, a person is 5 years 6 months. So I'm just taking an example here. So let's say Emily is 13 years old. Now she cannot be 13.6 years old. Another example of continuous variables would be, let's say, a person's height of a person. Let's say there is a person B, and the height of that person is let's say 5 feet 11 inches. So that is 5 feet 11 inches, that is 71 inches in total. So obviously this person can have, it's not necessary that this person will have 5 feet 11 inches only, like dot. This person can be somewhere a little bit less than 5'11". This person can be a little bit less than a little bit more than 5'9". So this person can say, let's say 69.5 inches, or let's say 68.23 inches. That's possible. So these are continuous values. So even if this person is between 5'10" and 5'11", it can take a lot of numbers. It can take infinite number of values if you keep on going to decimal points. Like it's like that. So within a range, continuous values can take a large number of values, and the discrete has to be an integer, because obviously it cannot be divided. Now categorical variables are also a part of random variables that we deal with. Categorical variables are, let's say, the variables, let's say a company, Mercedes. Okay, Mercedes has this let's say tires, and tires are of different classes. Let's say class A, class B, etc. And these are not numbers, these are classes, which for our machine learning algorithms we might have to turn into numbers. There are multiple ways of doing that, which we will later on talk about when we talk about feature engineering. Let's say we have gender. Again, that is male or female. Let's female or male. Again, this is not number, this is a category. So a very simple example of using infographics is a company and its revenue, which I just mentioned here. It's in a graph format. So let's say there is this company which has $25 million in revenue, then we have $78 million in revenue, $125 million in revenue. This can be anything like $125 million, $125.4 million, or $98.67 million. It can take any number of those values because it is continuous. Similarly, if we look at this graph and we have Chantal at the age of 23, this is age and these are people. Let's say the same example that I gave earlier, family members. Emily is 42 years Emily is 42 years old. West is 19 years old. Chloe is 85 years old. She must be the grandma. I don't know. I didn't talk about them. I didn't talk to them. So Ashley is 17 years old, and we have Maggie, 42 years old. But these cannot be, Eldon cannot be 63.75. James cannot be 14.74. So a very simple example that I talked about random variables. So simply speaking, very basic foundation of statistics to move forward to machine learning is to have a basic knowledge of what random variables are, what their types are, and what are numerical, what are categorical, what are continuous, what are discrete. Once this is done, we move on to mean, median, and mode. We'll see correlations, we'll see covariance, we'll see standard normal distribution, what distributions are, Gaussian distribution, normal distribution. Basically, Gaussian and normal are the same thing. We'll see different types of statistical measures such as performance metrics. We will see confusion metrics. These are the basic foundational principles of statistics that are necessary. Chebyshev's inequality, central limit theorem. We need to understand all of these to be able to understand how machine learning model actually is looked at, how it is described. How will we know it's working perfectly or not? How would we know our distributions, our data set? How is it? Do we need to make any changes? Do we have any missing values? Do we require to make some sort of feature engineering steps? Do we need to clean the data or not? I will be looking into all those things as well. I'll be explaining those step by step in different playlists. First, we'll start with statistics. And each time when we look into some sort of project, I'll be discussing how in industry it works differently, because when we talk about normal projects like looking at Kaggle or looking at some basic repository and just downloading a data set and doing something like an ML algorithm, applying that on the same, it doesn't really work like that in the real world industry, in the real world data. It's very dirty data usually that we get, and we have to do a lot of work on that. We have to talk to the stakeholders. That's an important communication that we need to do. There is screening that needs to be there from the stakeholders. There is a lot of scrutiny around the models that are being used. What kind of value that we are providing? Are we generating revenue? Are we giving some sort of return on investment to the stakeholders, to the company that we are working for? Are we cutting costs, saving costs in productionizing that ML algorithm? Productionizing is another thing we'll talk about much later. That is an end-to-end pipeline and how it works, ML ops. So we'll be talking about all those things step by step. I have just started with this small playlist for statistics, and we'll keep on moving step by step into different, much more convoluted principles of AI as well. See you later. Thank you.